Hi, Graham Balachi here from Building Blocks for Modern Humans. Thank you for joining me. In today's episode, I'd like to introduce the topic of energy, which is the primary building block into modern human lifestyles. Some consider it the master resource. So this video is for people that want an introduction to why humans use energy, how humans use energy, and where that energy comes from and how that fits into modern human societies. So if you've made it this far, please like this video and subscribe to this channel, and let's get to it. Harnessing and tightly controlling various forms of energy into performing work that is valuable to humans is the key ingredient to the magical world where our indoor temperatures are regulated, our food is refrigerated, global communication is near effortless, and international travel has quickly transcended from a weeks or months long grueling endeavor to a comfortable, affordable, safe, and relatively quick experience to almost anywhere on the globe.
Energy consumption is so important that this graph here shows an important story. On the vertical axis, we have the Human Development Index, which comes from the United Nations. And really, the closer you get to 1, so the higher up here you go, the better the standard of living in a particular country is. On the horizontal axis below, we have the energy consumption per capita. So this is how much energy each person in the country is consuming on average. And what you see here is that by, starting at the bottom left here with a country like Nigeria, as we increase energy consumption, you very quickly see a rise in the standard of living. Up until the point where maybe see here at about 200 million BTU per capita, we start to get into the European countries and the standard of living that's found there, and the North American countries and Australia as well. You'll also notice that it doesn't take all the energy in the world. There is a leveling off effect here where beyond about 200 million BTU per capita, it doesn't make a huge difference, but it does make a difference early on. So this energy consumption is incredibly important, which is why I want to focus on it as one of the key building blocks, the master resource into the standard of living for modern humans.
So, what is energy? According to physicists, which is where I always like to start, energy is the ability to do work, which might seem a little mysterious. The way I like to think about energy is it's things that are moving, or it's the potential for things to be moving. So really it's energy that can be released and things get moving in different ways, or it is a stored form of energy where things have the potential to be moving. And that's how we can control it. Between storing it and releasing energy, we can control it into our machines and our devices to do things that we want it to do. So now let's go over a few of the more common forms of energy you might encounter in your day-to-day life. To start off, let's take a look at thermal energy, or simply put, heat. You can use this to heat your living space, cook food, control chemical reactions, or something as simple as boiling water and using the steam produced to move things like in a steam engine. Most often we access heat by burning things, something we're all familiar with. And when I talk about energy as things that are moving, you can think of heat as all the tiny atoms that we talked about in the previous video from the elements of the periodic table, all those atoms moving around faster and faster and faster as they get hotter. That's thermal energy. When it comes to more obvious examples of things moving, we have what's known as mechanical energy. And this is things that are moving, or interestingly, as I alluded to before, have the potential to move. The best way to think about this is a spring. You can pull the spring apart, and now it's not moving, but if you let it go, boom, it comes back together. And that is the potential for it to be moving. So you put energy into that potential energy, and then it gets released into movement energy, which is known as kinetic energy. Both of these things, potential and kinetic energy, come together to form mechanical energy. Another common form you may be familiar with is electrical energy. This is electrons, which from our last video we know are the tiny particles on the outside of the atom moving through wires and performing work within our electric and electronic devices. The next example is radiant energy, the most common form of which you may be familiar with is light. Light is mysterious, but it's more or less made up of tiny particles called photons that move at the speed of light. There's a lot more examples than that, but we'll stick with that for now, and let's take a look at how energy behaves in the world. So there's one law in physics that you really have to be familiar with, in order to understand how energy behaves. And it's this:
The first law of thermodynamics, which states that
energy cannot be created or destroyed. There's only a certain amount of energy, and it is constant in the universe. What you can do with energy, though, is you can transfer it from one place to another, or you can transform it from one form of it to another. So, an example of energy transfer when it comes to mechanical energy, which again is just big things moving, can be as simple as a human swinging a golf club and striking a golf ball. You put your body's energy into that golf club, which then strikes the ball, and that mechanical energy is transferred from the club to the ball. It's still the same form of energy, it's mechanical energy, but you transferred it from the club to the ball, and hopefully it goes where you want it to. Usually it doesn't for me. Another simple example could be your stove and the heat from your stove being transferred through a pot into water and heating that water up. Again, it's all the same form of energy. You're just transferring it from the stove into the water, one location to another. That's energy transfer. Now let's think about energy transformation, which is transforming it from one form to another. An example of this could be burning fuel in an engine. When you burn fuel in an engine, what happens is the heat released from that burning causes the air to expand. And that air expansion can drive a piston, which creates movement in the engine and thus the vehicle. So you're turning thermal energy from the burning of fuel into mechanical energy, which is your truck or car moving. Another example could be an electric motor. In this case, we're taking electricity, running it through a motor, which creates an electric field, and there are other magnets inside that motor, and they repel each other, as you may have ever experienced when you push two magnets together, and causes it to spin. It's arranged in such a way that we can transform electrical energy into mechanical energy that we can use to do whatever we want. So now that we have an understanding of some of the common forms of energy that we encounter in day-to-day life, and how the first law of thermodynamics dictates that energy can be transferred from one place to another or transformed from one form to another, we can start to understand where humans get energy from and how we transform it and use it to do the work that we need for modern human living. So we'll go over the different sources of energy in detail over a series of videos. What I'd like to do today is give you a snapshot of the energy mix, which is the various different sources of energy and how much of each one we use. I get this information from the International Energy Agency, who produces these reports online that I'm accessing for free. According to the IEA, in 2019, this is the global primary energy mix.
primary energy refers to the first place that we got the energy before it's transformed into any other form. So this is literally as a raw resource where we got the energy from.
You'll see different percentages coming from different energy sources. That gives us an idea of how much energy we got from each one.
Coming in at the top right there, we have coal with 26.8% of the world total energy supply. Next is oil at 30.9%, and then natural gas at 23.2%, nuclear at 5%, hydro at 2.5%, biofuels and waste, which is mostly agricultural crop residue, at 9.4%, and wood and things like that, and other, which is mostly renewables, coming in at 2.2%.
What you may notice here is that the combination of coal, oil, and natural gas adds up to
80.9%
of the total primary energy supply that humans used in 2019. So the vast majority of energy comes from what's known as these sources, which are fossil fuels. These are ancient plants and animals that have been buried in the ground that humans extract out of the ground and then burn for the heat. That is the vast majority of the energy that humans used in 2019 and to this day. If you also include biofuels and waste, these are also fuels, typically waste products from agriculture, that get burned. So you combine these together and you start to realize that
90.3%
of all the energy that humans use on this planet starts from burning things, literally.
In comparison to the world total energy supply, this is the world total final consumption by source. So this is after certain transformations of one energy form to another have occurred, and this is the final form that they're actually consumed in by humans. You'll still see that coal, oil, and natural gas add up to 66.3%, which is a huge amount. And you'll see there's a drop on the coal in particular down to 9.5% as its final form, because a lot of that's being turned into electricity, which is at 19.7%. Other things contribute to electricity as well, but obviously the fossil fuels are still dominant here.
These fossil fuels are a finite resource. There's only so much of them on this planet. We still have a lot out there, so it's not any immediate panic, but it's something we do need to think about, is eventually we do have to replace these energy sources. There's a lot of talk about using alternative energy these days in the form of the other category that the IEA had on there, which is these renewables, solar, wind, and geothermal. And I want to talk about those in an upcoming video. The goal today was to figure out what is energy, how it can be transferred from one place to another, how it can be transformed from one form to another, and to take a look at the primary energy mix of where humans get energy from. I think we accomplished that. Again, please like and subscribe and leave some comments below if you have any questions, and I'll answer them. And I look forward to hearing from you. Until next time.